Okay, good morning everyone. In this session we will be discussing about series positive clipper. So in this case the diode will be connected in series with source and as well as load. That's why the word series, and the circuit will be used to clip the positive portion of the given waveform. So that's why it is called a positive clipper. So together it is a series positive clipper. So series positive clipper should consist of a source. So let me consider an alternating source where the diode is connected in series with the source in such a way that it has to remove the positive portion of the given waveform, and there should be a resistance, a load resistance. Okay, let me consider Vi is the input voltage, and RL is the load resistance, and the voltage across the load resistance, let it be it is an output voltage V0. Okay, so this is what your series positive clipper, and let us discuss the operation of this series positive clipper, how it clips the positive portion of the given waveform. So for that, let me consider this diode is an ideal one. So in the first case what I will be discussing is for an ideal diode, and under that ideal diode the case 1 is during positive off cycle. So during positive off cycle, what happens actually, this terminal will become positive, this is what the circuit, and this terminals will become negative. This is what the positive off cycle, and this is your anode, and this is cathode, this is your load resistance. Okay, so here the cathode is connected to positive and the anode is connected to negative through a load resistance. Therefore it is in reverse biased condition. As I already discussed, the reverse biased condition of a diode can be represented by an open circuit switch. So this is what during positive and during negative, and in this case the V0 is equals to I into RL, as according to Ohm's law. V0 is equals to I into RL. So no current flows through the circuit because of open circuit, therefore I is equals to 0. Therefore V0 is equals to 0 volts when the input voltage is positive. Positive means it means more than 0 volts. Clear? This is what during positive off cycle. Let me take this equation as 1. Okay, and let us go for case 2. Case 2 is for during negative off cycle. So let me write the same circuit during negative off cycle. Okay, and this is what the diode, the load resistance, and during negative off cycle the waveform will be like this, and the cathode is negative and the anode is connected to positive. As we know that the current always flows from higher potential to lower potential, and higher potential is represented by positive sign and the lower potential is represented by negative sign. It means here the diode is in the forward biased. Since it is in the forward biased, it is replaced by a closed switch like this, and the current flows in counterclockwise direction. Let me consider this is the current I, and whatever the voltage across the resistance is what V0. So from this V0 is equals to I into R according to Ohm's law. I into R is also equals to Vi, that is input voltage Vi. So it means during negative off cycles simply the output voltage is equals to input voltage when Vi is less than 0 volt. This is equation 2. Let me write the equation 1 and equation 2 together in order to obtain a mathematical expression for series positive clipper, right? So during positive off cycle means when the input voltage is greater than 0 volts, the output voltage V0 equals simply 0 volts, right? and when the input voltage is less than 0, it means during negative off cycle, the output voltage V0 is equals to Vi. This is very important mathematical expression which is used to represent what? A series positive clipper. Okay, and in view, let me write this waveform for the series positive clipper. Let us consider an input sine wave. This is what the input signal which is given. Okay, and these are the references. As I already said, for ideal case, the 0 volt will be the reference. Okay, 0 volt will be the reference. From this, with the help of this mathematical expression, Vi is greater than 0, V0 is equals to 0. It means during positive off cycle, this is positive off cycle. During positive off cycle, V0 simply equals to 0. Right? During positive off cycle, this is positive, from here to here it is positive. V0 is equals to what? This is your Vi and this is your V0. V0 is simply equals to what? 0. And during negative off cycle, you can see here, during negative off cycle, when Vi is less than 0, V0 just follows the input. It means the output voltage just follows the input voltage, so that you will be going to get this part. And again during positive off cycle, so from here to here, the diode will be in the off condition, and here diode will be in the on condition, off condition. In this case, the positive portion of the given waveform has been clipped. So that's why it is called what? A positive clipper. Clear?